Okay, so what have we seen so far? We saw that the sum or difference of a rational number and an irrational number is always irrational number. Okay, so the sum or difference of a rational number and an irrational number is always an irrational number. Okay, the product or quotient of a non-zero rational number with an irrational number is always an irrational number. So if you take any rational number, any non-zero rational number, and you multiply it with another irrational number, you will always get an irrational number. Okay. If we add, subtract, multiply, or divide two irrational numbers, the result may be rational or irrational. So if you add, multiply, divide two irrational numbers, you can either get a rational number or it can go out of the box or out of the bag and become a rational number. Okay. Okay, now let us look at some problems. Okay, so first thing I want you to understand is multiplication is a short form for addition. So when we write 3 plus 3 plus 3 plus 3, this is very, it takes a lot of time. So for this, we write short form as 4 into 3. So actually multiplication is a short form for addition. So when we write 4 into 3, we mean we are adding 3 4 times. Okay. So now using this, let us try to add root 2, which is 1.4142 and root 2. So we are adding root 2 2 times. We get 2.8284 for this thing. Okay. Now I'm trying to multiply 2 into root 2. See, because here I added 2 root 2 2 times. So I am multiplying 2 times root 2. So that is 2 into 1.4142. So I can see, you can see that the answers are same. So root 2 plus root 2 is 2 into root 2, which is 2 root 2. See, in linear equations we might have learned, or in algebra we have learned 8 into x. So this is into, this is the variable x is 8x. So in the same manner, 2 into root 2 is 2 root 2. Okay. Okay. Now let us add two irrational numbers. Okay. So we have 2 root 2 plus 3 root 2. So 2 root 2 is root 2 plus root 2, because we are adding root 2 2 times. 3 root 2 is root 2 plus root 2 plus root 2. So 2 root 2 plus 3 root 2 is actually the 2 root 2's, and here we have 3 root 2's, and when we add them we'll get 5 root 2's. Okay, so it is like 3x, I'm sorry, 2x plus 3x. What will be the answer? 5x. So in the same manner, we just add the constants here, or not constants in the case of algebra. Like in the same manner, we add irrational numbers. Okay. So this is, I'm just trying to connect it with what we have learned in algebra. So now let us look at another example. 2 root 2 plus 3 root 7 plus 3 root 2 plus 3 root 7. So this is like 2x 3y, again 3x 4y. So what do? We add the root 2 terms together. So 2 root 2, 3 root 2 will be 5 root 2. 3 root 7, 3 root 7 will be 6 root 7. So this is like you add the x terms together, 5x, then you add the y terms together, that will be 6y. Okay. So that is about adding irrational numbers. Okay, so if you can connect it with the algebra that we have learned in lower classes, so we add the same terms together. Okay, now let us try subtracting. We have 5 root 2 minus 3 root 2. So we have 5 root 2's here, from which we subtract 3 root 2's, and our answer will be 2 root. So again, 5 root 2 minus 3 root 2 is 2 root 2. So we have 2 root 2. Another example, plus 3 root 7 minus 3 root 2 plus 3 root 7. So here we have 2 root 2 and negative 3 root 2. So that will be a negative root 2. Here we have 3 root 7, and when the minus sign goes in, that will be negative 3 root 7, and that will become 0. So it's like 2x 3y minus 3x 4y. I'm sorry, it's not 4y, this is 3y. So 2x minus 3x will be minus x, 3y minus sign goes in, that will be minus 3y, and it will be 0. Okay, now let us look at multiplication. So we have 2 root 2 into 3 root 2. So we have 2 root 2 into 3 root 2. So I am using distributive law. So the first root 2 into this whole thing plus the second green root 2 into the whole thing. So when I'm multiplying, now I'm multiplying the red root 2 with each of these 3 root 2's. So that will be root 2 into root 2 will be 2, root 2 into root 2 2, root 2 into root 2 2. Again, when I multiply the green root 2's inside, that will be 2 plus 2 plus 2. And when I add them up, I'll get 12. So we have learned in the case of algebra, see for example 2x into 3y. So what do? We multiply the constants together, then we multiply the variables together. So that will be 2 into 3, 6, x into y will be xy. So in the same manner, let us multiply 2 root 2 into 3 root 2. First I multiply the numbers, the rational part. So that will be 2 into 3, 6. Then I am multiplying the irrational part. Root 2 into root 2 will be 2. Okay. So 6 times 2 is again 12. See, the answers are same. Let us try another example. Let's see. 3 root 5 into 2 root 5. 2 root 2. So first we multiply the rational parts. 3 into 2, that will be 6. Now root 5 into root 2 is root of 5 into 2. Like we learned before, root of a into root of b is root of a into b. So root of 5 into root of 2 is root of 5 into 2, which is root 10. So 3 root 5 into 2 root 2 is 6 root 10. Now let us look at division. So we are dividing 8 root 15 by 2 root 3. So 8 root 15 we can write it as 8 into root 3 into root 5, because root 3 into root 5 is root of 3 into 5, which is 15. Okay, so nothing is changing here. We're just splitting root 15 into as root 3 into root 5. Now in the denominator we have 2 root 3. So we can, this root 3 and this root 3 will cancel out as 1. 2 and 8 will cancel out as 4. So we have a 4 remaining there and a 5 root 5 remaining here. So the answer will be 4 root 5. So I hope you understood how addition, subtraction, multiplication and division of irrational numbers work. Okay. Now let us look at another topic, which is In the second section, section 1.2, we had seen how to represent root n on the number line for natural numbers. Like we saw root 3, root 5, root 7, and so on. So now let us see how to represent root a. So where a is any positive number on the number line. So the difference between this case and the case that we learned is there we used only natural numbers, natural whole numbers. So in this case we learned how to represent irrational numbers like root 3.5 or root 0.1 or root 9.9. So any positive number root, so root a, where a is any positive number, we learn how to represent root a on the number line. Okay, so here we were trying to represent root 3.5. So first I do is I make a line. I call its length as x. Okay, and the length x is 3.5 centimeters. Okay, so I am calling this length as x is equal to 3.5 centimeters. Okay, next what I do is so I call the endpoints as a and b. Okay, now from b I make a 1 centimeter long line segment called bd. So the brown part is x 3.5, the red part is 1, so the total is 4.5. Okay, so next thing is now using this the bigger line, so AD, I try to find the center of this line segment. Okay, now after finding the center of the line segment I call that center as O. Okay, now using that center and using the radius or using the center, I try to construct a circle. Okay, so I have found the center. Okay, this is my BD. Now using the center I take the radius and I construct a big circle. Okay, and the diameter of that circle will be AD. Okay, now AB. Okay, so this green line, this whole line, this is x. Okay, the BD part is 1. Okay, now x was 3.5, so x could be anything, so we are just treating it as x. So BD is 1 centimeter or 1 inch or 1 meter, one unit. Okay, x is what we wish to find, so x could be anything. Okay, so next what I want you to understand is this AB is x and BD is 1, so half of that will be x plus 1 by 2. See, AD is x plus 1, so half of that, which is AO and OD, see we are dividing it into half, so that will be x plus 1 by 2. Okay, till AB is x and BD is 1, so the total diameter by 2, that is x plus 1 by 2. So since this is the radius, this line segment or this length will also be x plus 1 by